Briefly explain the concept of quark confinement. Quark confinement is the principle that explains why isolated quarks have never been observed. Quarks are always found bound together in groups to form particles such as protons and neutrons. When attempts are made to separate quarks, the energy required to do so increases as they move apart, making it impossible to isolate individual quarks. Compare and contrast alpha, beta, and gamma radiation in terms of their properties and penetrating power. Alpha radiation consists of alpha particles, which are helium nuclei, 2 protons and 2 neutrons. It has low penetrating power and can be stopped by a sheet of paper or even the outer layer of human skin. Beta radiation consists of beta particles, which are high-energy electrons or positrons. It has moderate penetrating power and can be stopped by a few millimeters of aluminum or plastic. Gamma radiation consists of gamma rays, which are electromagnetic waves of high energy. It has high penetrating power and requires several centimeters of lead or meters of concrete to effectively shield against it. Define the term half-life and explain its significance in radioactive decay. The half-life of a radioactive substance is the time it takes for half of the radioactive nuclei present in a sample to decay into their daughter nuclei. It is a constant characteristic of each radioactive isotope and is used to measure the rate of decay of a substance. The significance of half-life lies in its predictability. It allows scientists to estimate the decay rate of a radioactive substance and determine its stability or usefulness for various applications. Explain the process of nuclear fission and its role in nuclear reactors. Nuclear fission is the process in which the nucleus of an atom splits into 2 or more smaller nuclei, releasing a large amount of energy. This process typically occurs in heavy isotopes such as uranium-235 or plutonium-239 when they absorb a neutron. In nuclear reactors, controlled nuclear fission is utilized to produce heat energy, which is then used to generate electricity. Control rods are used to regulate the rate of fission, and the heat produced is used to generate steam, which drives turbines connected to generators, producing electricity. Explain the principle of superposition and how it applies to the interference of waves. The principle of superposition states that when 2 or more waves meet at a point in space, the resulting displacement is the algebraic sum of the individual displacements produced by each wave. This principle applies to the interference of waves, where waves overlap and combine. Depending on whether the waves are in phase, constructive interference, or out of phase, destructive interference, they can reinforce or cancel each other, respectively, producing patterns of varying amplitudes. Define refraction and describe its applications in optics. Refraction is the bending of light as it passes from one medium to another with a different optical density. This bending occurs because the speed of light changes when it travels from one medium to another. Refraction is used in various optical devices and phenomena, such as lenses, prisms, and mirages. Lenses use refraction to focus light, prisms use it to disperse light into its component colors, and mirages are caused by the refraction of light in hot air layers near the ground. Discuss the concept of polarisation and provide an example of its application in everyday life. Polarisation refers to the orientation of the oscillations of transverse waves, such as light waves, in a particular direction. One common example of polarisation in everyday life is polarized sunglasses. These sunglasses are designed to reduce glare by selectively blocking light waves that are vibrating in certain orientations, thus improving visibility and reducing eye strain, especially in bright sunlight or when driving. Describe the phenomenon of diffraction and explain its significance in understanding the behavior of waves. Diffraction is the bending of waves around obstacles or the spreading of waves as they pass through narrow openings. It occurs with all types of waves, including sound waves, water waves, and light waves. Diffraction is significant in understanding the behavior of waves because it demonstrates their ability to spread out and change direction when encountering obstacles or passing through small openings. This phenomenon has implications in various fields, including optics, acoustics, and radio communication, and it helps explain phenomena such as the spreading of sound around corners or the interference patterns produced by light passing through narrow slits. Define the terms displacement, velocity, and acceleration, and explain their relationships. Displacement. Displacement is the change in position of an object in a particular direction. It is a vector quantity, meaning it has both magnitude, the distance between the initial and final positions, and direction. Velocity. Velocity is the rate of change of displacement. It is a vector quantity defined as the displacement of an object divided by the time taken to cover that displacement. Velocity indicates both the speed and direction of motion. Acceleration. Acceleration is the rate of change of velocity. It is also a vector quantity, defined as the change in velocity divided by the time interval over which the change occurs. Acceleration can involve changes in speed, direction, or both. Explain Newton's second law and its role in understanding dynamics. Newton's second law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Mathematically, it can be expressed as F equals ma, where F is the net force applied to the object, m is its mass, and a is its acceleration. This law is fundamental in understanding the dynamics of objects and is used to calculate the motion of objects under the influence of forces. Discuss the concept of momentum and its conservation in collisions. Momentum is the product of an object's mass and its velocity. It is a vector quantity, indicating both the direction and magnitude of motion. The principle of momentum conservation states that the total momentum of an isolated system remains constant before and after a collision, provided no external forces act on the system. This principle is often applied to analyze collisions between objects, such as in sports, car crashes, or particle physics experiments. Describe the relationship between force, mass, and acceleration in circular motion. In circular motion, the force required to keep an object moving in a circle is called centripetal force. This force is directed toward the center of the circle and is responsible for the object's acceleration toward the center. According to Newton's second law, the centripetal force is equal to the mass of the object multiplied by its centripetal acceleration. Therefore, the relationship between force, mass, and acceleration in circular motion is F equals mac, where F is the centripetal force, m is the mass of the object, and AC is the centripetal acceleration. Explain the concept of simple harmonic motion, providing an example from everyday life. Simple harmonic motion, SHM, is a type of periodic motion where the restoring force acting on an object is directly proportional to its displacement from the equilibrium position and is directed toward that position. A common example of SHM is the motion of a pendulum swinging back and forth. As the pendulum swings, it experiences a restoring force, gravity, that is proportional to its displacement from the equilibrium position, causing it to oscillate with a constant period. Define Young's modulus and tensile strength, and explain their importance in materials science. Young's modulus. Young's modulus is a measure of the stiffness or elasticity of a material. It quantifies the ratio of stress, force per unit area, to strain, change in length per unit length, in a material under tension or compression. It is an important property in materials science as it helps determine how materials will deform under applied forces and is used in designing structures and materials for various applications. Tensile strength. Tensile strength is the maximum stress that a material can withstand before failure occurs, typically when it is subjected to stretching or pulling forces. It is a measure of the material's resistance to breaking under tension. Tensile strength is crucial in determining the durability and safety of materials used in engineering, construction, and manufacturing.